Okay, we'll get started a little early because I think everyone's here. Welcome to the Lightning Talks. Did everyone have a good lunch? Yeah? Okay. What we're going to do is I have a timer up here. The speakers get 5 minutes, and then hopefully some really loud noise will happen. They're allowed to finish their sentence, provided the sentence isn't too long. Otherwise, we'll pull them off stage, and then they finish. Okay, so it's very simple. Um, I will let everyone introduce themselves, if that's okay, because I don't know any of you. Well, I do now, but I don't know enough about you.
Yeah.
Okay, and then they'll switch as quickly as possible. Okay, so that's how we're going to do it. Be nice to them, give them a round of applause, and help them out, encourage them. And we don't have time for questions. Okay, so you can find everyone if you have questions later on. Okay, so here we go. Game on.
All right, I will tell you a bit about Aurelia. That's a framework I discovered some month ago, which is really awesome, and I will just show you some stuff of it. What you get is a dependency injection system, a router, two-way data binding if you want. You can do custom elements, custom attributes, whatever with it. You have HTTP clients, an animator system, pretty much what you expect from a decent framework that is like a bit newer than Angular maybe, and yeah. I see it as an alternative to Angular 2, which is probably finished a bit earlier. The stack, which is optional for use, it takes JSPM as a package manager to install your dependencies and stuff. You should check that out anyway if you're using Aurelia or not. JSPM works well together with System.js, which is like a polyfill for this JavaScript module loader spec. They also will adapt it if the spec changes, because this is still not final. JSPM basically writes the configuration for System.js. Then you can use Bubble or TypeScript for the transpilation of your JavaScript code to ES5. Aurelia is based on ES 2016, some stuff they use decorators, but it's written in TypeScript. Actually, they changed it because they want to have a strong typed language, which ES 2015 doesn't give you. So in Aurelia, everything is basically just a JavaScript object. It has this concept of view models and views. So this is like a view model. It's just a class. You got a template. Here you see you have this variable text, and you use it in your template. That's basically it. You have this life cycle of a view, just methods you implement, and they get called from the framework. And like your view gets activated, you have this function, you can do something at this point in time. Or the deactivate you can use to like remove your event listeners, whatever. That's how it uses a custom element. You see this say hello tag there. You have this to bind. Here you see the data binding. You just bind the value to the input field. That's how you could implement then this custom element. It's again just a simple object. You have this decorator there, bindable, so to gets the data binding, and the view updates when it changes. And you can call functions on your custom element object here with this click trigger. You see this peak, it will call this function. You got a pretty nice plugin system that you can use for third-party stuff or even to organize your own code. Basically, you have this bootstrapping phase in Aurelia. When it starts up, you get this configure thing. It will, when you load this plugin, it will call this configure function. You get the Aurelia config object. You register your resources there. From there on, you can use it. You see this JSPM line. That's how you would install a plugin from GitHub, which has just a package JSON that defines stuff in it. And then you could just call Aurelia use plugin, tell it the name of the plugin, it will load the file, and you got your hello world usable. But the project state, they say it's still in pre-beta. They will probably do this beta tag in some weeks. It's pretty stable. There are some API breaking changes which are well documented, so it's easy to adapt your code. Documentation is good for most features. For some of the newer stuff, it's not, but it will come. Some people have production applications. Third-party plugins are like coming. There's a registry for them. Packaging the application is a bit rough still, but yeah, it will get better. There's a Gitter channel with a lot of friendly folks where you can ask questions and answer questions from other newbies. Some links, project website, GitHub, the chat, and there's skeletons for a simple navigation application that you can use to start, and a plugin like how this is structured. You can just check out that code. That's pretty much it. 3 seconds left. Thanks.
Hey, perfect. Oh, it's not very loud, is it? Okay, how do I turn it off? There we go. How do I use technology? That one. Okay, here we go. Thanks.
I'm Ivan, and I'd like to share my excitement about
We'll give you that chance. Now I feel kind of bad.
Hello. Do you hear me all right?
Go.
Good. Yes. So my name is Ivan. I'd like to share my excitement about React.js from Facebook. And actually, it's not actually about JavaScript implementation, but about the whole concept. Because I think it's something totally different for interactive user interface programming. And speaking of which, I did it quite a bit. With those technologies, some of them very archaic, dating to the 90s, and quite different, but high quality, state-of-the-art at their times, well documented, object-oriented even, but they have something in common, so they all made me feel miserable. Like I spent hours and hours debugging some tricky user interaction when you scroll halfway through the list, then hover some button, then click something else and type some text, and another part of the application is not updated, or is in the wrong state, or is disabled, or is just not there. So let's imagine what would it look like to take this classical user interface design or programming approach to something completely different. Let's program a Quake game, a deathmatch for multiplayer. And so we would decompose this problem, so divide and conquer. We'll take this scene, chunk it into parts. So we'll probably introduce some domination elements, that because you have to dominate other players when they're playing. So there are, in this example, there are 2 headers, 2 footers, 3 bodies, and some bullet points flying around. So we would also introduce maybe CSS, colorful shooting styling or something, which would position all those elements and change their colors. And then we would program really complicated logic of collisions and elements influencing each other, changing the scene lighting, overlapping of particles, flying out of exploding rocket, and so on. So we would put a lot of state and logic into these basically pixels on this canvas. And then the player turns the head. They would probably need to apply 3D transformations to all these pixels and polygons which are domination elements, to compute a new state of this scene. And do actually 3D games get written like this? No, they are not at all written like this. Instead, what happens is every new frame is just written on top of the current one. We throw away the whole frame and compute a new one. It's a pure function, referentially transparent, no side effects. So let's think, how would it feel, or how it would feel to program interactive user interfaces like this, applied to the web, for instance. That would feel pretty much like Web 1.0. So if you remember, it was we would have just a view object. It's on the left-hand side, and it has some properties which are rendered. And there is a hierarchy of templates, and data travels top-down through these templates with partials and maybe some helper functions. Like in this example, we would apply locale-specific formatting for the date and for the currency amount. And so we just throw away the whole page and render the whole new one every time. There is no accumulated rotent state, no cascading updates, which drove me crazy. So UI, user interface, is a pure function. But still there is interactivity. But reaction to interactivity is postponed to the next frame. And that actually changes everything. And I believe that's much larger than JavaScript, and it looks very promising for interactive UI programming in general for the observable future. Thank you.
$21, $20. Still has some time. Okay.
Where is it? Can I get? Okay. Yeah. Okay.
Go.
That clicks. Okay. Great. Hi, I'm Memi. I will talk to you about designing for disaster, or designing, how is it called? Designing for the worst case. And one example I always found very fascinating is Zurich's water supply. Zurich is an awesome city, and it has an awesome water supply. So we can drink water from the faucet, and it's mineral water quality. It's great. We don't have to treat water. It's just perfect. But we don't have one water supply. We have two water supplies because we're awesome. And the reason behind that is we have different sources, and they are kept separate. Like we have seawater here, and groundwater and source water here. And they're kept separate for a very specific reason. And this reason is these fountains here, which are Zurich's emergency water supply. So water from those fountains is not the same water that comes out of the faucets. And the reason is these fountains help in cases of disaster. If the household watering supply is polluted, for example, people can fetch water from these fountains. Now, these fountains don't look very practical. They won design awards for several reasons, because you can stand up here and drink, and there's a thing for the dogs, but they don't really look really practical if you want to get a bucket of water. And what they actually have, this here is a door, and you can open it, and there is a hydrant in there, and you can attach a whole piping system where people from the neighborhood can come and fetch buckets of water to get to their houses and have water at their homes. So this is a system that was implemented in the 60s, 70s, time of Cold War and disaster, nuclear pollution, whatever. And yeah, there is about 80 fountains like that all throughout the city, in all the neighborhoods. And it's part of the backup system of the town. Why do I tell you this? Yeah, obviously, I want you to think about designing for failure and designing for disaster and designing for the worst case. And there is a lot of opportunities in our work to do so. And examples are basically all that who's told the first talk this morning? That was, no JavaScript, low bandwidth, flaky connections, offline, inconsistent content. That's all like scenarios that are really bad, and we have to cater for them. So whatever you design for the web, think about the Zurich fountains. Thank you. Thank you.
We could change the format and just have everyone here do a talk the whole afternoon.
Okay. No, it's fine. Okay. Can I start? Do I need to use just 5 minutes? Can I use more since I'm the last one?
No, I'm afraid not.
Okay. Okay. Hello, everyone. I'm Alberto. Do you know this talk here? What? Okay. I took a bit of inspiration for this one. So, how many people of you know this guy? Okay. Yeah, it's Brendan Eich, or Brendan Eich, since we are in Zurich. Yeah, he invented JavaScript in like 10 days or so. And yeah, well, not everybody likes JavaScript, but sometimes it's also because people just start using it without really knowing what they are doing. Also because they have to work, right? So in this talk, I just want to talk a bit about some cool features of the language. Let's start to talk about the arrays. So we know that checking whether a value is actually an array is a bit complex. In JavaScript, we know that if we use just the double equal sign, it's going to return false because there are different instances. So let's hack JavaScript and let's do something like this. Array equals not an array, and it's actually going to return true. We could leverage maybe the type of operator, but it's going to return object, so because the array is an object. So what we could do is instead use the instance of array, but in some cases it's not going to work. Who knows where it's not working? Okay. So iframes break instance of array. And that's because if we have, for example, this test array here in an iframe, if you use the instance of array operator to check whether the array is actually an array, it's going to return false because array stays in the main frame. So there is a nice hack or feature that we can use to check whether it's actually an array, and it works. But actually now there is a method that you can use to check it. I don't know which one it is. Come on. Okay, it's array.isArray. Going forward, let's talk about undefined. Undefined is a beautiful keyword of JavaScript because you know that on some older browsers, for example, on Internet Explorer 8, we can just overwrite it, and we can define it as something else. Who has to support here Internet Explorer 8? Yay, Internet Explorer 8. Yeah, maybe some people are not going to appreciate our creativity, but you know, there is a solution also for this. So in this case, you can just wrap all your code with this iffy and just keep the last argument undefined and just pass nothing. So you're actually going to have really undefined, right? Yeah, so let's talk about null now. We know that null, if you use type of null, it's going to return object. which is obvious. We can also do fancy stuff like check what type is null plus null, which is going to return number. And that's because null plus null is equal to 0, and many people here speak German, so it's probably obvious to you, right? So do you know why type of null returns object? Yes, because it's an object. Because it's an object. The specs say so. So the specs say that type of null should return object. And if you go deep into the specification, actually, it's a null. It's a primitive value that represents the intentional absence of any object value. So just deal with it. It's JavaScript. Okay. So to end, I have none. We all love none. None stands for not a number. We know that not a number is actually not a number. So it's not equal to itself. And if we check if what type is not a number is a number. And so if you're confused, you can just use the is none method, which is going to return true for none. Now, if you remember earlier, we checked what type is array. An array is an object. So an array is not a number, right? No, it's actually an array is a number, but well, if you go and check what type is an array, it's going to return false. So well, okay, it's fancy stuff. So the API is kind of broken, but do you know what can you use now to check whether none is actually none? Okay, it's ECMAScript 6 or number that is none. Shut up. Okay, that's all. Yeah, all of these could only be possible just because I use the double equals and just because coercion. Yay! Thank you.
Good job. Let's give a hand to all the lightning talkers. Good job. It's hard to come up and speak, and it's definitely hard to come up and speak when you only have 5 minutes to do so. And there's this limitation, this fictional limitation that we put on it. So it's a great job, and it's amazing that people are actually trying to recreate everything we used to do on the server with client-side JavaScript, right? So we're going to set up the next speakers. We have till 2 o'clock, so if you want to go get something else, you can. If you want to hang around here, you can. And we'll get started in about 12 minutes.